Hey guys, and welcome back. Today we're going to be talking about unit rate and how it relates to slope. So yesterday we talked about how slope is the same as rate of change, which has the word rate in it. Think back to 7th grade when you learned about unit rate. Unit just means 1. So we're going to be trying to calculate the slope where it's per 1 of something. So our learning target is going to be to determine the slope of a line and interpret it in terms of the context, as well as calculate and interpret the unit rate. To be successful at this, we first need to be able to calculate the slope of line, which we've practiced a couple times and we're going to practice even more today. We're going to be able to reduce a fraction to a denominator of 1, no matter what the numerator is. And then lastly, we're going to interpret the unit rate and slope in the context of the problem. So let's take a look at the key idea here. A rate is a ratio that describes how one quantity changes as the other quantity changes. You can find the unit rate from a graph in the same way that you find the slope. So really, if you're asked for a unit rate, just think slope with a denominator of 1. So if we're going to find the unit rate of this situation here of the plant club contest, where the plants are given a certain number of weeks to grow and then you're supposed to measure the height, this particular plant, it shows at time 0 it was at a height of 2, and then, or I should say at week 0 it was at a height of 2 inches, and then at week 3 it was at a height of 6 inches. If I want to find the unit rate of this, how quickly the plant is growing, I'm going to use those 2 points and plug into the slope formula, which is the change in the y-coordinates over the change in the x-coordinates. That formula was y2 minus y1 over x2 minus x1. Remember, we should label those points, the x1, y1, and the x2, y2. So let's call this the first point, and let's call this the second point. This would give me x1 and x2, whereas this is y1 and y2. So now I'm ready to plug into my formula. y2 is 6, y1 is 2, x2 is 3, and x1 is 0. So now the rate of change of this line, 6 minus 2 is 4, 3 minus 0 is 3. The rise represented the height, so that's 4 inches, and the run represented the weeks, so that's 3 weeks. So this slope, or this rate of change, is saying that the plant is growing at 4 inches every 3 weeks. But a unit rate wants this to be 1. So we need to change this to a 1. But we can't just cross off the 3 and make it into a 1. It still needs to be an equivalent fraction. So what we're going to do is we're going to divide both the numerator and denominator by 3 in order to make the denominator 1. Because 3 divided by 3 is equal to 1. That's our main goal, to make the denominator equal to 1. Well, what's 4 divided by 3? You could write this as 4/3, or you can write it as a decimal and round it. Just to make it a little easier to understand, if you're explaining it to someone, you probably wouldn't say, oh, the plant grew 4/3 inches. You would probably say a whole number and a decimal. So 4 divided by 3, I'm just typing that in my calculator, and I'm going to round the decimal I see to the 10th. So I'm seeing 1.3 repeating. Okay, so if I interpret this in terms of the context, again, the y value, or the up and down value, was the inches, so this is 1.3 inches, and then the x values, or the horizontal value, was weeks. So my unit rate is going to be 1.3 inches every week. So now that we understand the idea of slope is the same as rate of change and unit rate is the same as those two with just a denominator of 1, let's try our first example. It says the graph shows the amount of milk used to make a particular cheddar cheese. How many ounces of cheese can you make per gallon of milk? So really, all I want you to do in these situations is find the slope or find the rate of change and then reduce it down where the denominator is 1. Now, when you're finding slope, since I'm given the picture of a graph, I can just use a slope triangle. Make sure, though, that you're not counting the actual grid lines, that you're looking at what the value is that it rises. So the rise here is going to be 32. Okay, it went from 0 to 32. That's a rise of 32 ounces. And the run, to go from 0, 0 to the first point, right there, there's our run. Don't just say that's 2 units. Make sure you check the x-axis. And it looks like the x-axis, they're all labeled by 1s, so it really is 2 that we ran. So I'm going to make my ratio, my rate of change. I'm going to abbreviate this to ROC for rate of change, is the change in the y, the up and down, which is 32, over the change in x, which is the left and right, which it changed by 2. Now again, we should always reduce this fraction before we move on, which if we reduce it, both of these are divisible by 2. So it seems like just by reducing our fraction, we're going to get our unit rate. So our unit rate is going to be equal to 32 divided by 2 is 16, and 2 divided by 2 is 1. We should also put real-life context to this. This is a real-life situation, so I wouldn't just answer 16 over 1. I would say this is 16 ounces for every 1 gallon of milk. That is a very strange I. Hold on. There we go. Okay, written out in words, we would say the unit rate is 16 ounces for every 1 gallon of milk. All right, so let's keep applying this idea of unit rate when we read different rates in real life circumstances. So this example says your neighbor burns 88 calories in 8 minutes cross-country skiing. There's a proportional relationship between calories burned and time. It's important that they said it was proportional, because if it was not proportional, then we could not think about this as trying to find a unit rate. We would have to try to think about it in another way. So the fact that they said that it was proportional means we can just divide that 88 by the 8. And what I mean by that is, in part A, it says, what's the unit rate of calories per minute? Well, the rate of change is 88 calories per 8 minutes. Well, how do we get that 8 on the denominator to become a 1? We have to divide both the bottom and the top by 8. So the unit rate is going to be 88 divided by 8 is 11 calories per 1 minute. Part B says, use the unit rate to draw a graph that models this situation, where the horizontal axis is time and the vertical axis shows the total calories burned. What is the slope of a line? Now, I didn't provide a grid for this, so this might be a nice way for you to try to make a sketch. A sketch is just a rough drawing of a graph. So I'm going to sketch the graph. Here's the first quadrant. Okay, we want to be in the first quadrant because negatives don't really make sense for time and calories burned. And I'm also going to just put some tick marks on here and label them by 1s. Now, I know the tick marks aren't perfectly spaced, but that's okay. Again, I'm just drawing a sketch of this graph so that we can see the main idea of it. And then I'm going to scale my y's by 11s because I know that my unit rate is 11 calories every 1 minute. So it'd be easy to scale these by 11 and show that proportional relationship. So this would be 11, 22, 33, 44. Now I just plot a few points. I'm going to plot my unit rate. Since this is proportional, the unit rate is actually there. So for 1 minute that goes by, 11 calories are burned. That means if 2 minutes goes by, 22 calories are burned. If 3 minutes go by, 33 calories are burned. If 4 minutes go by, 44 calories are burned. Now I know my points don't look perfectly in a straight line, but that's because my graph is a sketch and my tick marks are not perfectly evenly spaced. I'm also going to draw a line through these points because even though it says we burn 11 calories every 1 minute, if you were to even exercise for 30 seconds, you would burn some calories. In fact, you'd burn 5.5. So I do want to draw a continuous line through these points showing that after time starts at 0, 0, you begin to burn 11 calories every 1 minute. The slope of the line is going to be the same as the rate or the unit rate. So you can say the slope is equal to 11 over 1 or just 11. All right, so this example says your friend borrows $200 from her parents. The graph shows how much money she owes her parents. How much is she repaying her parents per week? How long will it take your friend to repay the loan? So we got a couple of different questions in here. I'm going to highlight the two different questions there are here so that I don't forget what I'm supposed to write down as the answer. How much is she repaying her parents per week? And how long will it take your friend to repay her loan? We need to make sure we answer both of those questions. Okay, so first let's answer the first one. How much is she repaying her parents per week? Now I want to point out that it says per week. How much money per week? So that's indicating, what is the multiplier? Okay, remember the word per means multiply. So really the first question is asking, what's the multiplier? Multiplier is a synonym for slope, is a synonym for rate of change, which can also be a synonym for unit rate if the denominator is 1. So really they're asking us for slope or for unit rate in the first question. So let's take a look at the graph. If I were to pick out two integer value points on this line, I'm going to go with the easy one that's above 0. So there's an integer value point right there. Make my point a little bigger here. Okay, so right there, that's an integer value point. This is an integer value, another integer value, another integer value. Notice how I'm highlighting the points that are on cross sections of the grid lines. So I'm just going to go from the leftmost point to the next point I see. Okay, so I'm seeing from here, I'm falling, and then I'm running. Now, how many units did I fall? Well, I did just fall one grid line, but that grid line is worth more than just 1 unit. So to go from 200 down to 160, that was negative 40 units, okay, or negative $40. As for the run, okay, our x's are labeled by 1s. So really, I can just count the grid lines here. This should be 2 weeks. So now I'm ready to create my slope, my rate of change, my unit rate, whatever you want to call it, since they're all synonyms. So my slope is equal to rise, which is -40, that's the up and down value, over run, which is 2, that's the left and right value. Again, we should always reduce. -40 divided by 2 is -20. Well, what does this -20 represent? If you notice how they labeled the y-axis, that represents the amount owed to her parent. So she's owing $20 less every single week. When I say less, I mean that little negative symbol right there. So she's paying $20 every week that passes. I'm going to write that out in words because it didn't ask me just to identify the slope. It says, how much is she repaying her parents per week? So my friend is repaying $20 every week. The second question says, how long will it take your friend to repay her loan? So I want to know when she owes nothing, when she owes absolutely no money. Now it says she started by borrowing $200. If we take away 20 from 200, we get 180. Now you could just continue taking away 20, taking away 20, taking away 20, every single time until you get it down to 0 and then count how many weeks that is. You could also take this graph and extend it out, okay? What my recommendation would be to do is to take that 200 and see how many times 20 goes into it. So let's divide it by 20, because really that's what we're doing every time we're subtracting 20. I want to know how many times 20 goes into 200. Well, 200 divided by 20 is 10. So it's going to take 10 weeks for my friend to repay this loan.